This is Darren Marchant with American Nomad News with a station dynamics segment. Now, before we get into it, I would like to acknowledge all the people from the off-ramp who finance my food supply so that I can live and breathe and tell you all about this stuff I've studied all my life. I'd also like to thank Ocean Beauty Seafoods for the years of work in a factory that beat me up and made me miserable at the time, but I learned a lot and it helped to pay for me. And I'd like you to please go visit their website and apply for a job so that other people can experience exactly how hard that stuff was. But no, they're great employers. They work up in Alaska, they're based out of Seattle, and they've got some fantastic people working for them. They have not sponsored this video, but they helped to sponsor a portion of my life. So please, go check them out. That's Ocean Beauty Seafoods. Now on to the video. Oh, like, subscribe, comment. Comment, please, I need comments to help feed the discussion. I don't really care as much about the algorithm, except that I really would like to get monetized, which I'm not right now. But I want more people to see this so they can discuss it with me so that it helps me to break down questions. I want to know what your questions are about how all this could work. So station dynamics. In this train of videos, we're not talking about the moon and Mars yet. Those are special cases. What we're talking about is microgravity, and especially a Aldrin cycler transport that is like a ferry. It cycles between the Earth and Mars, and it actually overshoots both. Excuse me, I got a little hiccup trying to come up. Okay, and in the other videos, and please go watch them first, catch up. The station is scalable. It's based off of a equilateral pyramidal structural tessellation. If you can deconstruct what that means, please ask questions in the comments. The scale of the cells are imagined in this scenario as being 3 meters on a side, made from struts that can compress or extend, but snap back to a standard length. They also have a lot of room to have different kinds and sizes of centrifugal rotations, but here's where sympathetic motion comes in. You don't want your overall station to spin. That can cause significant problems, and it puts a load, a structural load, on the overall station that you don't want to have to deal with and design for. And that means that for every centrifuge, you have to have a pair. Otherwise, it'll transmit its direction of rotation to the station. So if you have a centrifuge, here's my little burnt up paint can I use for storage and sometimes to make coffee. And you have it rotating, right? And it's attached at the axle to the station. That's going to it's funny how it works, but it'll translate a sympathetic motion to the station, and the whole station will want to move with it. And so because you'll have a constant rate on this to give you the G, it'll constantly be adding, it's additive to the rest of the station. So you need another one, right? You need 2 of them. So over here you got the other one is rotating in the opposite direction in the same plane. Opposite direction, same plane. Cancels out the sympathetic motion. You may find that a very small amount of rotation could actually be beneficial. It may help to move mist or water or loose objects to the outside of your station, and you may want that, and you may be able to do that with centrifugal management. Now, your centrifuges can come in a lot of different varieties. You may have small centrifuges that are designed to collect and condense water for pumping, because they would pull it out of the moisture of the air and spin the mist to the insides of a drum that's rotating very fast, and pump that water out of the pool of water that results in there, and then you've got encapsulated water in a pipe that has relatively little gas in the pipe. You may have a little bit larger centrifuges that are mostly pretty much just a cage, and put chickens in it so that they run around and they can peck and they can have a good old time. And you can, as you take plant cuttings, you might put them in there, and the chickens can stomp around on them and chew on them. And anybody who's had chickens, and there's more and more people who have chickens, they know that chickens will tear stuff up. If you put them on grass or in weeds, or if there's bugs around, they will tear that stuff. They'll tear into it. So they're really good for assistive pre-processing of compost. So you might have just a big spinning cage, and your chickens are in it. You may even let them wander around into microgravity areas in certain parts of the indoor farming. When your station is as big as several supersized sports stadiums, your chickens could have plenty of room to go. And you may even grow, doves for food. Like historically, Hebrew tribes used to grow doves. I think they were doves. Doves are pigeons. Not technically sure the difference. Ducks, geese, they like to fly. And you may experiment with growing them, raising them. They may prefer a centrifugal environments for roosting and playing around, but to give them some room, they might get used to navigating through microgravity air, floating on the breezes that you artificially create, and you may want to factor that in with your safety screens over larger fans. But they may enjoy floating around in that. It might work real well. It might be disastrous. You'll also have to deal with guano and how you process that guano. The guano, if you can get it to run through your compost and your water systems and break down properly, it might work really well for your plants. You may even have something like your vine crops or your bamboo crops growing in a mesh, like we talked about in some of the other videos, a quilt of composted material in burlap. And the birds are in a centrifuge that's spinning around. And here's a point where I should describe the difference between the experience of G here on Earth. G here on Earth is based on mass. And so up is out, down is in. We live on a ball. In space, G is going to be based on centrifugal effect. And that means up is in, down is out. And that means the underside, what you might, if you've grown chickens, the underside of the coop is the outside of the centrifuge. Okay, so what you might want to do is have the burlap batting in a skirt a few feet away from the bottom of your coop, which is a spinning thing. I should totally do a diagram of that. Yeah, I should do a diagram of that. Where did I put? Okay. Let's do a diagram of that really quick. And that should probably wrap up this video. Okay. Chalk. Okay. Now. Oh, I can't. not very easy because this is on selfie mode and I can't draw and show it very easy because I can't see the screen, and the screen is how I aim, so I can't do that. We'll have to get in probably the next video. I'll do a diagram of how to do a chicken coop in microgravity with mixed microgravity centrifugal, and how that can be designed into some other system, like maybe growing the bamboo. Bamboo might be really good for that because of a lot of factors. So yeah. So that's a little piece about station dynamics. Another piece that I got into is mitosis in the previous video, and that's a really interesting thing to consider. Mitosis on the scale of the whole station is that the station is scalable, and I haven't gotten into how the struts work very much, but that scalability means that you can constantly add to the size of your station up to a point where you decide you've got enough station to split it in half to have two stations. And the other station, one station can stay on the same cycler orbit, and the other one can fall back and begin to transfer to another orbital designation, so that they're separate, they don't run into each other, and they have other jobs to do. One might get into a parking orbit around Mars for a while and could drop food shipments quite easily down to the surface. Could drop industrial materials down to the surface that are produced from bamboo or resins. If you're growing pine trees, you're getting pitch, and you're getting pine oil, and you're getting lumber. Those could easily be dropped to the surface. Okay, not super easily, not as easily as Earth, because Earth has a thick enough atmosphere to slow stuff down. But these kinds of things can be done. Or could park in orbit around Earth and drop food down, or be a way station parked at a Lagrange point of the moon for a while, taking on people waiting for another station to swing by to transfer to go out to Mars. At some point, leave the parking Lagrange point of the moon and go off deeper in system, maybe establish a Aldrin cycler between Mars and Jupiter to drop off at some station out there. Could go into a solar orbit, a strictly solar orbit, maybe opposite the Earth in the same orbital plane and orbit. All kinds of options there. You can have these things buzzing around all over the solar system. And these can be very, very large. Like I said, they could be a couple of miles or more on a side, because you don't have the structural stress of putting everything in your centrifuge, because you don't have to, right? You don't have to have a von Braun. Von Brauns have much heavier design requirements due to all the stresses involved, and they have a lot less options for space. They're more cramped in their general design. Now, there's a couple of guys out there that I'm real impressed with. They're working on a von Braun style station, and I'm super supportive of that. I really want to see that happen, because that's a big step towards doing the kind of Aldrin cycler that I'm working on. Thank you very much. God bless, and Godspeed. It's reaching up about 15 minutes on the video, so this is where I'd like to remind you to like, subscribe, share, comment, hit the bell icon. God bless.